All right, fantastic. We are live. So, hello everyone, and welcome to the Golem 1.1 release update. So, the Golem engineering team has been hard at work, cranking away on feature after feature and bug fix after bug fix to deliver a really amazing update. And today we're going to walk you through that and actually give you a live demo of all the new stuff coming to Golem open source. So, I'm going to go ahead and start this off by sharing my screen and walking through a few slides. All right, here we go. So Golem 1.1 release update. So there's three major themes that are driving this release, and the first one is developer experience. So we made a decision early on that Golem 1.0 would be about providing the raw functionality necessary to stand up new backend services that run in a fault tolerant way with a minimum of frills and bells and whistles. And as a consequence of that decision, we were able to get 1.0 out the door, I think, in a reasonably short amount of time frame. Only a year and a half in development before we were able to launch that. The drawback is that in the last hackathon we did notice a lot of developers struggling with this issue or that issue and so forth. And it's expected, I think, because we focused on just getting the product out the door. But now we know we need to invest more heavily in improving the developer experience. Using Golem is possible right now. Using Golem 1.0 is possible, but it's not necessarily joyful. And that's because there's some tooling stuff that we have to work on. There's some sort of WASM ecosystem stuff that we have to address. And of course, we have to bring support to Golem for higher level programming languages, like, for example, TypeScript and JavaScript and C# and Java and all those other great things. That's way too much to do in just one release. So we had to pick and choose our battles for the 1.1 update. And I'll tell you about some of the stuff we decided to focus on in a moment. The second major theme of Golem 1.1 is extensibility. So as Golem grows, we need to be very careful and thoughtful in the way we expand its base of functionality. Basically, what we're looking to do as we go into the future is have this very small, very stable, well-tested, well-audited kernel of Golem that is responsible for the core operation and scaling and durability of the services you deploy on Golem. And then all the other stuff, we want to make sure that it's easy for people to add that, but add that in a way that doesn't increase the complexity of the core kernel or the cost of maintenance and auditing that. And towards that, what we're trying to do is make Golem an extensible platform. So if it doesn't have all the features that you want, you can add new features into it in a way that's not going to bottleneck on the core Golem engineering team or compromise the stability and robustness of the core offering. And then the final theme in the 1.1 release is batteries included. That's this notion which it's going to take us a while to get all the way there, but we're slowly starting to think about the bigger picture. And instead of just deploy some code and let you invoke it, we're starting to think about things like how can your code call other services? How can your code talk to other databases? How can you supply configuration? How can you supply initial set of files for your application to begin executing? And all of these come under the category of sort of having a batteries included experience that just gives you everything you need to build a new backend service without you having to go out and host some parts of your application on Amazon Web Services or whatever. You should be able to go into Golem and build and deploy an app and stay within that ecosystem. And I'll talk about what we're doing there in a moment. All right, so these are the big ticket items that we spec'd out and implemented for Golem 1.1. And one of them is worker to worker developer experience. So Golem allows you to deploy backends that are composed of different components that all talk to each other, just like in a traditional microservice-oriented architecture. And there are some differences there, um, leading, I think, mostly due to the fact that Golem workers are stateful. And so when you have one service talking to another, it's not just talking to any instance of that service. It can actually talk to a specific instance of that service, which we call a worker. And accommodating that was possible in 1.0, but it wasn't very easy. So we've done a ton of work to simplify the whole process of workers talking to other workers in a type safe way. In addition, we've launched a single executable, which is basically Golem plus all of its dependencies bundled into a single executable application that you can launch very simply from the command line. And that is not really suitable for production deployment, for sure, not, but it is very useful for local development and testing. So no longer do you need to use Docker or anything like that. You can just type some command from the command line, hit enter, and that spins up everything you need to do local development and testing. We've revamped and, dare I say it, reinvented the interface for Golem Cloud Console. So if you're taking advantage of our free developer preview where we're hosting Golem in the cloud, then you're going to see a tremendous amount of improvements in the user interface. The new UI is way easier to use, way more consistent, way more polished, and is coming to be quite a nice developer experience. Rib, which is a scripting language that you can use to quickly stand up new REST APIs that are powered by the functions that you deploy to Golem Cloud, has undergone some major upgrades in the area of stability as well as expressivity. Now you can pretty much do everything that you need to do with the functions that you are calling into from your rib scripts. You can process maps and lists and all sorts of other things that you couldn't do before. We've also introduced support for something called ephemeral workers, which we're going to talk through later. Golem is very, very good at durability. It's a durable execution platform, and it allows you to deploy very mission critical workloads without having to worry about failure scenarios like failure of a CPU or a server or restart or all of those things that go wrong in real world cloud development. You don't have to worry about any of them because Golem is a durable execution platform. But now we're also introducing the ability to run classic Lambda style workloads on Golem, because in reality, most workloads are mixed, right? There's going to be some percent, 10%, 20% that need to be mission critical and fault tolerant, because in that part of the code, you're touching 20 different systems and you have to do updates across all of them. And you can't afford to do updates in some and then not updates in the other. So you want to do something that is distributed system state update, basically. And we give you the tools to do that. But now we also give you the tools to do sort of throwaway workloads where you don't really care if it's reliable because it's only going to last a fraction of a second, or you're only updating one system, or you're just generating some HTML or whatever it is. So now you can do classic Lambda style workloads as well as those workloads that need to be highly reliable and might be long lived, all with the same platform and without any sort of change in usability and barely any change in feature set. We're adding plugins to address the extensibility aspects of Golem. We've added oplog enumeration and search to help with diagnosing things that have gone wrong in your workers. So now you can take a peek and see the full history of worker execution without having to write any log statements or whatever. You can see exactly what services your worker was calling into and what the success or failures of those calls were like. And you can search that oplog for relevant errors and URLs and all sorts of other things if you're looking for some specific piece of information that might explain a failure scenario that you see. We've also, under the theme of batteries included, we've added support for end user authentication. So now once you're able to very quickly build an application that then is going to support allowing an end user of that application to authenticate, and your worker doesn't have to worry about any of the OpenID Connect stuff. That's all sort of baked into Golem. So you can just focus on business logic instead of authentication and authorization. We've added support for cores because we know some of you are building end user applications, whether that's mobile apps or web apps, and you're trying to build your backend in Golem. So supporting cores here is necessary. And then we also managed to sneak in, due to our Bounty to Hire program that we launched, support for something called the initial file system, which basically lets you equip new workers with a set of files. It could be a SQL-like database. It could be static assets like PNGs and GIFs, CSS, and HTML that you want to serve as part of a web app, or it could be something else entirely. You get to decide how you use the initial file system. So as you can see, a ton of new features, and our engineers have worked very, very hard getting all of this stuff not only out the door, but also tested in time for release. Now what we're going to do is switch over to do a live demo of Golem 1.1 features, and leading this demo will be the very engineers who implemented these features, starting with Daniel Dukowski, who's been driving core platform development at Golem. Daniel?
Thank you. And hello, everyone. So let me share my screen first. And okay, I think it should work now. Yeah, so I will show you a few of these improvements that John just mentioned, focusing on the core platform features. And let me start with ephemeral workers. So as John already mentioned, until now, as Golem is a durable execution platform, basically every application that you uploaded to run on Golem was automatically executed in a durable way. You could write any kind of stateful application, and Golem guarantees that the state of your workers get persisted, and in case of any kind of failure, your application can continue running. But starting from the Golem 1.1, now this is an option, and we also support a new kind of workers called ephemeral workers, which are more like the traditional function as a service kind of way of just exporting something stateless, exporting a function from a worker. And when you are invoking this function, that will Golem will somewhere in one of the Golem executors will spin up a new instance temporarily just for running that particular function. And it's not stateful, it's not durable. It's just quickly running your code, and then it gets it won't get reused anymore. So there is not much to demonstrate about this functionality because by design, durable Golem workers and ephemeral Golem workers are basically looking and behaving the same in Golem. There is one difference, and the difference is that durable workers are always identified by a unique name, which we demonstrated previously many times, that when you are creating a durable worker, you give it a name, and then you can refer to that worker using that name basically forever, because its state is persisted forever. With ephemeral workers, this isn't the case. You don't have to, or you even cannot associate a name with these workers. You are just defining a Golem component being ephemeral, and then you can, when you are invoking a function, you are just referring to the component itself. There is no need to create workers or name them and so on. So if we look at the CLI, Golem Cloud CLI, you can see this is the latest version. One thing that related to ephemeral workers is how you define them, and this property, whether a component is ephemeral or durable, is tied to the component definition itself. If we try to add the new component, you can see there are some new flags, and one of them is ephemeral. So the only difference compared to what you were able to do before is that when you are uploading the new component, you can mark it as ephemeral, and by default, it's still durable. And it's important that you can change this later. So let's say you started working on an application and you thought that one component type that you are developing will not require any durability guarantees, and you started defining it as an ephemeral component, and you are uploading newer and newer versions, and eventually you realize that you need to introduce state to that component, and you don't have to refactor everything, create a new component for that, and so on. You can just, when you are updating your component, you can use these same flags to say that the new version of the component is now ephemeral or it is now durable, whatever it was before. And this works very similar to how other updates in Golem are working. In Golem, basically, a specific component version is an immutable thing. And if you started workers based on component version 1, and those were, let's say, durable, and later you decide that this component doesn't need durability, you switch it to ephemeral, that means you define a new version of your component, and your existing durable workers will continue running in a durable way. They will not be affected in any way based on this, by this change. Yeah, and so there is nothing really more that I can show about ephemeral workers. So let's switch to the next topic. And the next topic will be this observability feature called oplog search or oplog query. And to do that, I will get back to the example application that I was live coding in the Golem 1.0 launch. So maybe some of you have seen that. It's basically consists of 3 components. I will not go into their source code this time. I will just use the compiled versions that we created in the previous launch event. This is a demo application that implements a collaborative list editing application. A list is just basically a list of strings. You can think of it as like a to-do list or something like that. And multiple users can connect to these lists, add and remove and update items. And there is another component in this application called the email component, which is responsible for sending a notification to the connected users after a while, like a half a day or something, that they are still connected to the list and they didn't do any modification and something like that. And the third component, called archive, is a singleton worker that holds all the information about lists that were archived. There is an API exposed by the list component to archive a list, and then you can no longer edit the list, and the list goes to the archived component. So we are going to reuse these files, and we start by creating a new project for this. Sorry, cloud. Yeah, we are creating a new project in Golem Cloud for the demo. And we are going to save this URL here for further runs. Yeah, and so the first step is now this is an empty new project, so we have to upload these WebAssembly files. Let's do that, and I will use my history to avoid having to do. Okay, maybe it's easier if I just type it. So we are having a component, we want to add it into this project with this name, and it's in the pre-compiled email. So we have uploaded this. As you can see, it exports a single function called send email. And we are going to need this component ID. So I'm also saving it into the environment variable for the purpose of the demo. And the next thing, we are uploading a component called list, which is going to be this file. This will take a little longer because this one was implemented in TypeScript, and that is a bit more verbose. I mean, the WebAssembly file itself is quite big. So based on the internet connection speed, it can take a while. But it's done, and it exports a lot of things related to how you connect to these lists and add and delete and insert items, get the state, and so on. And finally, we upload the third component, which is called archive. And that's done too. And before we go forward, some more environment variables, just so it's easier to type things in. Okay, so we have these three things uploaded. We can check by Golem Cloud CLI component list of the specific project that we are working on. Here they are. So I'm trying to demonstrate the offload query. So we need to do something. We need actual workers that have some history of invocations to be able to demonstrate that. So I will just do a couple of invocations. And one is called yeah. So we are invoking a worker of the component list. The list name will be test. Function is API connect, and I'm passing an argument that is my email address. That will create this new worker and also add me. Oh, what happened here? Oh yeah, sorry, I skipped skipped one step. So what happened here is that our component is trying to do some worker-to-worker communication, and it constructed this URN where worker and unknown is the string that is in place of a component ID. And unknown is not a component ID, so this is not working. And the reason is we didn't pass. So there was a reason why I saved all these identifiers into environment variables, because you have to configure your worker. You have to pass the component IDs to it as a initial configuration in order for them to be able to find the different components in your system. This is actually something that we are also going to improve in the next milestone of Golem, but unfortunately, right now you have to explicitly start your list worker using the worker start command. I will give a different name because we already corrupted this one. As I said, Golem durable workers are persisting their state forever. So now this worker is remembering that it crashed forever until we delete it, of course. So what we have to do is we pass two environment variables to this component. So it will know the component ID of the archive component and the component ID of the email component. Okay, so now we have a worker named test2, and if I do the same invocation again, but now on test2, then now it succeeded and it returned ID1, which is our connection ID in this demo application. So the next thing to do is that we are adding a few items to this list using the add command. And that requires two arguments. One is this connection ID, and the other is a string, say item 1 and item 2. And I'm not going to demonstrate the other features. Let's just see if this modified the state of the list by calling the get function. Yes, it has the two items that I added. And finally, I'm calling the archive function on it. Okay. Yeah, so now we have three, yes, we have at least, we've seen that we are having one worker running. Actually, we are having three workers running because this was under the hood invoking our email worker and our archive worker. So we can actually verify that by doing Golem CLI worker list component name project. So we have two worker, one that was failed because I forgot a step, and the other is test2, which is the one that we were playing with. But we can also check the email component that is going to have one worker, which is actually suspended because it's waiting half a day for sending an email to us. And we have an archive component called archive, which is also, it was just created and its status is idle. So, okay, so now we finally arrived to the point where I can demonstrate the worker oplog search functionality. So the simplest thing that we can do is worker oplog command. And if we don't pass any other parameters, it will give us the full oplog of our worker. Actually, it needs a worker name parameter as well. Yeah, so this will give the full oplog, and the full oplog is basically all the information that Golem stores about the worker to provide the durability features. Let's see what happens. Yeah, so it returned 41 or 42 entries. And if you take a look, it starts with a create entry, which is when the actual worker gets initialized, it gets these environment variables that I first forgot to pass. Then there are things like invoke and call, and you can see it, for example, it was getting the environment variables from the system, and it returned all these different environment variables. For all the recorded calls, we can see the input parameters, the output parameters. We can see log messages, which were printed by our worker. And it's a lot of information. So let's see what else we can do. And we have a query parameter. And here we can try writing things. So like, for example, I'm interested only in the entries that are related to exported functions. So I want to see what kind of exported functions I was invoking, but I'm not interested in the rest of the entries. Let's see. Now we have pairs of invoke and invoke completed entries. So we can see first I invoke the connect function with my email address as an input, and then later it completed and returned with ID 1, and we can see all these different functions that we were adding with all the parameters and everything. And actually, this query parameter here is a Lucene query, which can be used to construct quite complicated query expressions, and you can even peek into use these input and result values in your query filter argument. So for example, if I want to get every entry that somehow contains the ID field, and the ID field is 1, I can also do that. And it returns me a couple of entries where there is an ID equals 1 somewhere in the in the data. And last thing to show here is we can also, so as I said, this worker invokes 2 different workers under the hood. The email component, it creates a new worker in the email component and the new worker of the archive component. And let's see, we want to understand this better. So I add the query expression RPC, and I can see 4 entries. Well, it's actually 2 RPC invoke entries, and the other 2 is just a record of generating an idempotency key for these keys, which is an internal detail of how we do exactly one semantics for worker-to-worker communication. So we can see that we were calling a send email function with this idempotency key and this parameter and so on. And we were also at the end, which is almost the last call, because I call the archive function at the end of the sequence of invocations. It calls the store function on the archive worker, and it passes the state of the list to be archived. So let's say that we want to see what happened in the archive worker when this happened. And for that, we can copy this invoke idempotency key from here, and we can query the archive worker's upload and just filter for this idempotency key. And by doing that, it didn't work because a worker name in this case is archive, which actually you can see somewhere here. Yeah, here. So let's try again. And now you see that after this RPC call, it first arrived as an enqueued invocation into the archive worker with these parameters, and then actually at the next step, it started processing this. Well, the enqueued invocation and invoke, the difference is that while you are in an invoke, you cannot. So there is always just one invocation running at the same time currently in Golem. So if somebody does another invoke while an invocation is running, then it is first recorded as an enqueued invocation entry, and then later when this invocation queue gets to that invocation, that it is recorded as an actual invoke entry. But you can see that with these tools, you can browse into what each of the workers were doing. You can follow links because everything is connected by these idempotency keys. And it can be a very powerful tool for debugging complex multi-worker, multi-component Golem applications. And in the future, this will be integrated to our Golem Cloud console web user interface as well for even better experience. Okay, so this was the new upload query feature. And now the next thing I wanted to show is that now if you go to the GitHub release page of Golem Cloud, this is the latest release that was done a few hours ago. And previously, even for 1.0, we already uploaded precompiled binaries of the Golem CLI here, which are these. But a new feature is this single executable Golem, which is also published for a couple of platforms, for uh, for Mac OS and Linux, for both x86 and ARM platforms. It's currently not published for Windows, but that is something that we will fix for the next version. So once you download one of these precompiled binaries, I did it before, and I copied it to a binary called Golem. It prints Golem CLI, but don't. That's just a small mistake. Golem, this Golem binary is actually a superset of the Golem CLI. So if you check the commands, it has all these things that we were using before: Golem component, Golem worker, and so on. But it also has a new command called Golem start. And by doing that, what will happen is that this is just a verbosity flag, so we see more logs. So it starts up all the components of a Golem cloud configured to run locally. It saves it, uses SQLite as a database and local file system for storing some stuff. But it's just a single native process running in your machine. And you can use either Golem or Golem CLI to basically try out stuff, do anything that you are able to do in a real deployed Golem cluster. For example, I could start doing the same demo with creating a new component add. Yeah, so I was doing this. Now I'm doing it with the Cloud CLI, with the Golem CLI component add. We don't have projects in open source versions, but I can upload my email worker, email component. It was added to our locally running thing. It logged that the component was uploaded and so on. We can start creating the workers. Basically, every functionality that is available in Golem open source is available with this single executable version as well. I will not redo the whole demonstration again, but it's quite simple to experiment with this version. And finally, a few words about plugins. So as John mentioned in the introduction, plugins are a new feature which are extension points for Golem. And plugins are not fully done in Golem 1.1. So I would say it's an experimental feature. We have an initial documentation for it, but we don't have good examples yet. And we don't support all the guarantees that we are planning to in 1.1, but this is something that will be finished and then be fully supported in the next version. But still, I wanted to tell a few words about it. We have two types of plugins, and one type is called a component transformer plugin. Actually, support for the component transformer plugins is more or less complete, but we are going to add the real-world examples and more documentation to have people creating component transformer plugins. So what is it doing? You can register a plugin, which is a third-party web service, an endpoint, which is going to receive every component that you, not every, but if the plugin is enabled for a component, when you are uploading a new version of that component, the WebAssembly file itself is going to be sent to this plugin, and it can modify it. And then Golem will run. Golem will store the modified version, and the workers you create will be created from this modified WebAssembly binary that the plugin was generating. And this can be used for a lot of different things. basically, these plugins can use WebAssembly component composition to alter the behavior of uploaded WebAssembly components. And one example for that is, let's say, your component is using the WASI key value store interface that Golem provides. And if you are not using a plugin and upload it to Golem, it will use Golem's implementation of the key value store interface. But if you are a database author and you have a key value store service running somewhere, you can create a Golem plugin that will compose the user's uploaded components with your own implementation of the key value store that connects to your hosted database or whatever. And then transparently, by switching on and off these plugins, users can modify what implementation their application is using by keeping the same interface, and no need for recompiling or rebuilding anything. Another example that a component transformer plugin could do, it could extend the API of a component with something. So it can take the user-defined component and it can compose it with some additional additional component that exports some additional API that every component that has this plugin installed will provide. And a third possibility is that you are not replacing what Golem provides, but you are wrapping what Golem provides. So for example, a very simple example could be you can write a component transformer plugin that wraps every host function that Golem does and just records it to some third-party log service, for example. So this is one type of the plugins. And the other type of the plugins is called Oplog processor plugins. And this is the one that is more experimental at the moment. But an Oplog processor plugin is actually a Golem worker running in the Golem cluster, just like any other worker. But it implements a special interface called Oplog processor. And I can actually show that. Oh, not here. So the Oplog processor interface is defined here. When you're writing an Oplog processor plugin, you are creating a resource called processor, which gets some information in its constructor about the account and the component and some configuration. But after that, it has a process function that will be periodically invoked by Golem itself, passing a list of Oplog entries. So these are the same Oplog entries that I was just showing with the Oplog query feature. An Oplog processor plugin, you can enable an Oplog processor plugin for a couple of workers, and Golem will broadcast everything they do in the form of these Oplog entries to your Oplog processor plugin, and it can, as it is a Golem worker, it can be durable, it can have state, it can do things like it can aggregate some metrics based on these incoming informations and so on. And once this feature is done, which is not in 1.1, we are going to guarantee that Oplog processor plugins are having an exactly one semantics regarding these Oplog entries. So if you enable a plugin for a worker, you can be sure that your plugin will receive every Oplog entry that was ever generated from the worker where you enable the plugin, and you will only get it exactly once. And there was already some functionality regarding plugins in the CLI, for example. You can register, unregister plugins, get information about plugins, and for components, there are new commands to install a plugin and uninstall a plugin to a component, and check what plugins are enabled for a given component version. And just like with the component type, which was durable or ephemeral, plugins are also immutable in this regard, that if you are enabling a new plugin for a component, that creates a new component version. It means that already running workers will be not affected by this. If you want an already running worker to have the effect of the plugin that you installed, you have to update that worker to the new version, which gives you total control in deciding what you want to do with your existing entities. So that was all that I wanted to share. And with that, I pass it to David, who is going to talk about the new developer experience features.
Hello, everybody. Let me share my screen. I'm not sure. Did it work or not yet? Not. Oh, okay. It asks for some permissions again. So, do you see my screen now? Okay, thank you. So, as Vigo and John mentioned, we wanted to improve several aspects of how worker-to-worker communication works. And part of this puzzle was creating a new format called Golem YAML. Let me just show a demo example. What we call the Golem application manifest format. We wanted to have a declarative format which can define component properties in general, so they can be used for interacting with the command line interface in a better way, so you can store that in your next to your component source code. And the other important aspect was to define all the worker-to-worker connections and dependencies also in a declarative way. Previously, we provided in Golem CLI, as you can see, the stubgan command, which we now consider deprecated, and we have a new app command, which stands for the application manifest. And we wanted to do so because with stubgan, it was possible to create all the necessary stubbing and linking and composing. It was sometimes quite error prone if there were multiple components involved. And also it had different processes depending on what kind of language is used, how to interact properly with these. So I already prepared this project. This is actually one of our examples which can be created with the Golem CLI new command, which called the TypeScript multi-RPC example. Here, let's open it. Here we have 3 TypeScript components, which are currently quite unhappy, as you can see, because they are missing all their stub dependencies and other kind of dependencies, all of them. And let's check their with definition. They are just derived from the very basic example we use many times, which are just a counter, which adding getting, only with the twist, which is for technical reasons. The component one calls component 2 and 3 and delegate the add call, and component 2 calls component 3. And as you can see, currently it's not really, even according to my IDE, it's not in a happy state. Let's check the Golem YAML files in this project we have. First of all, I would like to highlight that we are providing JSON schema for these YAML files, which depending on your IDE or editor, you can set up in similar ways. And that will help with code completion and other features. And also it serves as a documentation, at least a small one. So it should be easy to start getting using the application manifest format. Let's see how it looks like. So as we can see in the project, there are multiple Golem YAMLs. One is in the root, which defines some temporary directory. As we can see, it includes some global pattern for finding other Golem application manifest files. And it also defines a template called TS, which stands for TypeScript. And it defines a few things, which I will talk a bit more about, but quickly some source, some generated with and wasm sources. And also it defines how to build TypeScript components, which, as we can see, sometimes not that easy because it involves several steps, including stub generation, which creates the binding, for the with packages. Then we have to compile the JavaScript itself, the TypeScript into a JavaScript file. Then we have to componentize it. And again, depending on the language, these might be quite different. And we can also see that it uses some sources and targets. We will see why this is important. Now, as you can see, currently I'm pretty empty with these folders. Not much is happening here. Let's just try out what the Golem cli up command can do. So if I just run it, it seems that we can build and clean. Let's do the build one. And after some seconds, hopefully, we can recheck what happened inside the project. While this is building, also let's check one of the component Golem YAMLs. We can see that all these are much smaller than the root one. So for example, component fund just states that it uses the TypeScript template. But if I would want to redefine some properties, I could do so. So these properties can be defined directly on components or through templates or override them. And as you can see, we also define dependencies called, for component one, we define two dependencies to component 2 and component 3, which was an RPC. And similarly, we have this for component 2, and for component 3, we do not have any dependencies. And let's see what happened. Just if we quickly look through the logs, we can see that first the up command tried to search all the application manifest files it can find depending on the folder and the aforementioned glob patterns. After that, it merges all these sources into one document, and now we can see it found 3 components called component 1, 2, and 3. After that, it resolves all the user-defined with directories and some generated folders, and based on those, it makes decisions. Also, it selects some profiles, which is not relevant for TypeScript. We will see how that works with a Rust template. And now comes the part where we generate many different temporary with and wasm artifacts. And this is the part which was kind of hard to in the previous iterations, because you always had to know which of these should be done at which time. But because we have a declarative approach, the Golem cli up command can create and order all these dependencies and do the right transformations and build steps at the right time. So after all of these generating and stop creation, eventually we start building the actual components, and you can see that it will involve calling all those defined build steps. And finally, we are linking together the component and the stub components into a final wasm components, which are now ready to be uploaded to Golem. So let's see what happened inside my file structure. Now we have a folder, and all of these wasm files are appeared. We can see several temporary stuff which we should not care about. Oh, sorry. So these are the directly built components, and these linked components are the final one which can be uploaded to Golem. But we also don't have to care about. I will show you in a second. And now if I open this, it's magically the file became happy, because now, as defined by many of the previous steps, from this with definition, through some transformations and the dependency resolutions, we generate a new with folder where we extract all the exports of the component, which you can see here. So we extracted many parts which are used for breaking cyclic dependencies. And also all the referenced stubs are now part of my dependencies. And as you can see, the original folder didn't contain dependencies, but all of those got resolved. From where? Where it was defined in the Golem root Golem YAML that I have a with depths folder, which actually contains my dependencies, that anything I refer, and if it can find it in one of these directories, it will automatically resolve this. This means that if I have some dependencies and I might drop them or reaggregate them, I only have to include them at one directory in my project. Now, this project compiled, let's try to build it again. We see that this time it was very fast because although all of the previous steps are trying to be run, but all of them are skipped. And this is why it's important that if meaningful, the sources and targets defined for the different build steps can have a huge impact on build performance, because this way we can do up-to-dateness checks based on modification times, but also the Golem clean up command stores the success or failure of previously executed tasks. So if I were to change, and again, if I run it again, it's still not doing anything. Let's say, which was previously quite usually hard to do, define a new worker-to-worker connection or dependency. I can do that with the dependencies key. And now I will add for component 3 to, let's do the part 1. It will call itself, so this is one kind of cycle. And the type of this dependencies was on RPC. Currently, we're only providing this one, but eventually there will be other kind of interactions. And let's define another one. We go back to component 1, if you remember, which we're calling this component directly and indirectly. So we have now 3 kind of loops in this simple application. Let's see what happens if I run this. We can see that we are skipping many things for component 1, but for component 3, we have some work to do. This is the first time when component 3 is actually called. So component 3 defined its dependencies, so we have to regenerate all of its stuff. And eventually, we see that most of the things were not changed, but component 3 have to be rebuilt, and now it is containing linked dependencies to component 1 and component 3. This also means that now in the binding, I can see that all these interfaces, which were previously not here, appeared for the proper components which were required. And similarly, if I were to delete some of these and rebuild and clean the project, all of it should rewire itself without having to manually delete things. So to see some other usage and examples of how the application manifest works, I will do something which usually probably not something people do, but again, a feature of Golem is using multiple languages in the same project. So for this, in this repository, I will use Golem CLI new, and I will use the example called Rust default. I will create a new component called component 4. It is done. We can see it's here because we defined our patterns in a way that we're only searching for components in this directory, even though it will look a bit weird. I will put this component into this directory. So this is now a Rust component with a very different build style. Let's check out this application manifest. This one is, because it's a one component template, uses defining directly the component properties, but because in Rust is very common to use debug builds for local development and release ones, it also uses profiles, which is a feature in the application manifest format. First, let me rename this to match better this repo. So component 4 can be built in two ways and has two sets of properties. One is the debug one. We can see that here, as the building blocks, we will use the debug component. And for release, this is a little bit different and uses the release build. So, and also let's check the width for this component. I will also use component 4 here to match it. So again, if I just run Golem CLI up build now, hopefully, oh, I get an error because template is defined in multiple times. So it has a lot of validation, which tries to prevent misuse of the format. Let's fix that. So some of the, as I said, there is merging going on, but we expect that some of the root properties should be defined only in one of the application formats. No, this should be good. And let's see what's happening. We are skipping many things, but eventually we see a Rust build tool in action. Okay, this is just because I renamed the component. Let me fix the error here. So this is called component 4. Let's build again. And now we are done. And we should have, so this component definition builds into the Rust target folder. And now I have a new debug button. Let's build a release one for this. For this, we can use a flag called build profile, and we will choose the release one. And as you can see, now we have a new Golem component created. There are other ways how the Golem application manifest interacts with the command line interface. And for now, the first, I would say, more convenient feature is that if I want to deploy, let's say, this component, I can just say component add, and so in normal, if we are not using application manifest, I have to define exactly where is the final build WebAssembler component. I have to make sure I'm not using an intermediate one. I have to use the final good one. But now we can just say component name, for example, and component 4. And did I use a wrong name? Or 3, maybe I use. Okay, so this one succeeded. For the component 4, I'm not sure what I wrote wrong. Let me recheck my. But anyway, the point is that now the component add and eventually more and more commands will also use the application manifest as a source for component properties. Another few more dotted things we can use the application manifest right now is that we can define, for example, the newly added component type, which can be durable or ephemeral. And by default, it's durable. And also, this is the main way to interact the new feature called initial file system, which means that we can add files to our component definition. And anytime we start a new worker, the worker will have these files ready and available to be used. So to demo this, we can, let's use the Rust component we used before. which is, this is the mismatch. So it's called Golem component 4. Let's change the name. It should just work fine. So now I want to deploy this. Okay. Now I will, for the debug builds, we will do something with the files. Let's define the initial file system. So a file system definition consists of a source path, which is a local one. And again, this is not something we should do in production, but just for testing purposes, let's mount the source code of the component itself. And then define the target path. This will the path which will be available for the component to access this file or the worker when running. So I will just call this source. And finally, we can define permissions, which can be read-only or read-write. For now, we will use this read-only one. And just to show that it actually works, I will open this component 4 in Rastrover to edit it. And let's make it a little bit bigger. So it has this two call. I will just, as a very small demo, let's use fs read to string, where we will read this source tx text file. And then we will match on this. In case we got the content, we will just print line it. In case it failed, we will just print the error for demo purposes. Now again, let's build our application. It seems that it built, and let's deploy. And notice that I will only have to mention the component name, and it will also find all the component properties that will upload the relevant initial file system. Yes, let's update it. And let's invoke this component as a final test. Oh, but sorry, so let's create a worker. So invoke and await. The component name is component 4. The worker name can be anything, like 1. And we will also connect, which means streaming the standard output and the standard error of the component. Let's define the function name. And if it works, then we should. Did I do something bad? Probably. So probably I messed up something in my local environment, but we should see the uploaded file. Okay. So these are the main use cases of the application manifest files currently. The documentation is not done yet. So for now, I recommend checking out. Some of our examples are already ported, and the schema can be used as a smaller documentation to see those properties and play with them around. And I think I will pass to Afsa, is it? Yeah.
Thanks, David. Okay, let me share my screen first. I have to quit and reopen because of permission issue. Sorry about that.
So while Afzal is restarting his Zoom, just a brief note that this application manifest file, we're going to be using it as the basis for a whole host of new simplifications to the command line experience. So look forward to see those in 1.2. Welcome back, Afzal.
Thanks, John. So today I'm going to demonstrate some of the new features and functionalities that we added into the Golem gateway space as we presented in 1.0 launch event. Gateway API gateway of Golem allows you to expose HTTP endpoints over the worker functions quickly. And this gateway is also embedded with a language called as RIP, which allows you to manipulate inputs to the worker functions, as well as manipulate or transform the output of this worker function to send it as an HTTP response. The new features are included not just in the gateway by itself, but there are improvements within RIP language too. So what I'm going to do now is to showcase one simple example that goes through all of these features. On a high level, we added authentication support, which implies you specify a security scheme and your worker calls will be authenticated from an end user perspective. And we will also go through how we can enable CORS in API definitions. And thirdly, we will go through some of the small little features that was added into RIP script. And we will, if we have time, we will go through some of the other small little improvements that we have done as part of 1.1. So the first thing is authentication. So let me show you an API definition. I hope you can see the screen properly. So this is sort of a big API definition, a relatively big API definition with 4 routes, but we don't care about many of them except for 2 of them. So here I have a simple post endpoint with an add item path, and it talks about a component which I have already uploaded. We have gone through how to deploy and define the API definition and deploy the API definitions, etc. So I'm not going to explain it again, but on a high level, this is how you define API definition, and you specify the component ID as part of the binding. The default binding type says that it will communicate with the worker. Here, there is something interesting where I'm specifying the worker with my name. And obviously, this route is very normal example, simple example without any security. It is just like before. The only thing is I am inlining the name to form my worker name. And the response is simple: add the item with some request body. So it mandates the fact that your body should contain what add item is expecting. And then we respond it with a body and a status and required headers. And there is nothing special here. However, we have another endpoint, which is just getting the cart contents. So this is adding item to the cart. And now the next endpoint is getting the cart contents. And at this point, I'm saying I have a security enabled for this route, and you just specify the security scheme name. I will explain what that means. Essentially, you can think of this as providing the identifier of the security details. And what is a security detail? I can explain that later. So specify the security, and now you are able to look up the name of the caller, name of the end user. Here I'm using given name, which will be Afzal. And then my worker will be exactly the same worker as where we have added the products into the cart. So before I explain further, let's see this in action. Let's try and call that endpoint with that security enabled from my browser. So it goes into Google Identity Provider. And now I have a very dumb example of an HTML page. And this is coming from exactly the same worker where I have added the cart, where I have added the products into. So the name of that worker, you can see my worker Afzal. And here in this get endpoint, within my rib script, my worker name is exactly the same because I could look up the given name from the authentication that was done using Google Identity Provider. So now you can understand that shopping cart security scheme is a detail about the credentials that you have in your Google Identity Provider when you have registered your app. So to explain it again, you have an app, you registered that with Google Identity Provider, and you got a client ID and client secret. That's your security scheme detail. Now, first thing that we need to do is to register that security scheme, and that's very simple. You just use Golem CLI, create the security scheme, provide an identifier, and you know the provider type is Google, which is important. There are most of these providers work exactly the same, but in this example, I'm using Google. And I already know the client ID and client secret, and most importantly, a redirect URL, which is a common concept in all the identity providers that you have. Now I can explain one more thing. This is OpenID Connect protocol. So all of the authentication workflow that you just saw is an OpenID Connect protocol, which is embedded within the gateway, API gateway. So you don't need to re-implement this in your backend, which is probably worker. So once you added this security scheme, just provide that security name within the route, and thereby your endpoint is authenticated now. And what does that mean? In your rib script, you can look up given name, you can look up email, name, anything which is supported as claims in your OAuth workflow. Okay, I have got some pictures. Okay, so that's it. When it comes to authentication, there is nothing more that you would need to do other than specifying the security scheme. Register the security scheme with client ID and client secret, and then just specify that in your route. And thereby, everything is authenticated. And obviously this is session store, which implies we don't need to go through the same workflow again and again. And I think there are two expiries here. Golem has its own session expiry, and the tokens that are coming into play has got their own expiry. Regardless of the type of expiry, you will get a redirect. And if there is any signature mismatch or CSRF token attacks, possible attacks, then it's not a redirect, it's unauthorized. And let's go through what is being done here. Here I have said hello Afzaltaj, which is which is just looking at the name. The name here is just request.auth.name. Email, I have got email here, a given name here. And just to understand that my worker name is obviously request.auth.given name, which will be the same worker. And that's it about authentication. Now, as part of the same example, I would like to explain some of the new simple things that was added into the RIB language itself. The two most important features that were added was for list comprehension and list reduction. So here I am calling the worker function and getting a result back. And you can look up the schema of, or look at the types of these inputs and outputs from the component output, like using Golem CLI, or if you're using Golem Cloud, you will get to see what is the exact output of get card contents. And in future, you'll have some auto completions and hints about what is the output of result. But here you can see this get card contents is a list of records. And each record is a product information. And I don't care about rest of the product information. I just care about product name. So I loop through the result and just get the product name. And now product names is a list. This is only for demonstration purpose. You can do it in different ways. Now I'm concatenating it, just forming an HTML out of those names, which is going through each of those product names. So this is each element, which is each name, and this is an accumulator, and this is the initial value of the accumulator. And if the initial value is empty, then I'm just returning the element itself. Otherwise, I'm concatenating that accumulator with the element, and then I'm yielding it. So this implies, and you can see I'm having these HTML tags in between, and that is why this is working. And these are not duplicates. Essentially, I gave the same name for all the products. And let's try and add one more product just to make it clear. So I've added, or maybe let me change the name. Maybe M4, even if it doesn't exist. So you can see the two new products out there. And that's all done by that RIB script I just showed you, which is demonstrating the two new features of RIB. With that, authentication part is done. And we have taken extreme care to make it as easy as possible to do the authentication. There shouldn't be anything more required from the user level. But that said, there are numerous ways people can use authentication, which we understand, and that's in our radar. So what we have done is making sure that we have a platform in Golem code base to add all of those nuanced, subtle way of users handling authentication, because many times people just need a token back and then separately handling things by themselves. But we can add all of those details as we go, but we have got this platform ready now. So with this, I have explained two features, the new syntax for list comprehension and reduction in RIB, as well as authentication. The next thing is enabling CORS. That's also very simple. So here is one endpoint, which doesn't have any CORS enabled, but you can see the resource as v1 user ID hello. And what it means to enable CORS is just provide the pre-flight endpoint with options method. This is optional. So once you enable pre-flight endpoint for that resource, CORS will be enabled for all the operations for the same resource. That's it. If you have custom requirements for your pre-flight, you can write a RIP script itself. This is actually a RIP script. This is a WASM record. And here you can specify the headers. And you might be familiar with these headers, at least for those who have worked with CORS, you are familiar with these headers, and just specify the CORS headers as a WASM record. And you can specify all the supported one. I think there is one more, which I can't quite remember. And then this will work. So what the browser will use the pre-flight requests, and the get endpoint will now have the response headers specifying the codes. So for example, here you can see access control allow origin, which is a response header, but we haven't specified any of that in the API definition, and that's because you have enabled the pre-flight request. And you can see the pre-flight request itself with all the access control headers. And that's it about CORS. It's made that simple as much as possible. And it's also inspired from some of the existing API gateways, such as AWS, where you define the pre-flight endpoint and everything else is automatic. Now let's go through some of the other improvements that we have done as part of this release. So now you have used a component to register an API definition and then deploy it. But what happens if you go ahead and updated that endpoint with some incompatible changes while your API is being deployed already, and that's live? So we have got a restriction here that says you can't just go and update the component, because the new component, I have just said, it's a completely different WASM compared to shopping cart, which will make sure that none of those functions exist. Here you can see it says this Golem IT API, add item and get cart contents are in use, and you can't just update with the same name. And functions with conflicting types, it's basically, there is none here. It implies, say we have an add item that takes different types of parameters or more number of types of parameters, then that will be listed here. So that is component constraints. So it'll make sure that your live APIs are always working. And the third one is, or probably the fourth one is, I have mentioned in the API definition some of these requirements. So for example, this RIP script requires authentication details in the request, in the input, and that should have a given name in it. And similarly, in the response mapping, you have several requirements here. Again, one is from the path. It looks like it needs some information from the path. It needs some information from the auth. So how do you document this? And to solve that problem, API gateway in Golem auto document your requirements of input as well as output. Let's see that in action. So here you can see response mapping input, which provides, hey, you need in your request field, you need auth, and within auth, you need email. So this serves as a documentation, and we can emit this as different formats, for example, OpenAPI in future. But as of now, this is much better represented in the Golem Cloud UI because it's very difficult to understand what's going on just with this JSON. But this is a proof that everything is auto-documented. I think that covers most of the new features that we have developed in the gateway space. With that, I will hand it over to you, Nico.
All right. Can you guys hear me? Sweet. So I'm going to go ahead and share my screen, and I'm going to talk about the UI, the Golem Cloud Console. Let me get this organized. All right, much better. So well, I specifically worked a lot on the console for the 1.1 release, kind of changed the entire layout of everything and made it a little bit more ergonomic and intuitive. And so what we're going to do here is kind of step through creating some components and then also invoking workers. And in that, talking about the file system, the initial file system, which everybody kind of referenced already, but it'll be nice to have a visual aid to that. And then we will step into creating APIs, kind of building off what Afzal has already shown us. So the first thing that we're going to do is that we're in a project right now. So we're in the Golem v1.1 demo, and I'm going to go ahead and create a component. So that's the project. We're going to just create a simple counter component, make it a durable worker, select the WebAssembly, and then I'm also going to select some initial files just for the sake of example. So basically, on a component level, you can specify what the file system structure should look like for when your components are actually running at runtime as workers. So I'm basically supplying 4 different config files. Imagine these have runtime relevant information. And right now they're all specified as read-only. If you wanted these to be read-write, you would unlock them. You can also like put them into a folder saying config, and then kind of drag a few of them in there, and then you have kind of a nested structure. So we'll go with this for now. So basically a counter component with 4 config files and their relative places. So we'll go ahead and create a component, and then bam, once we uploaded the component and created it, we step into this component view. So a project has components, and we can see that because we just created it, we have no workers created. So it's a fresh component. So what we'll do here is actually before we create a worker, we're going to go to the Files tab and just look at the file structure for that we uploaded. So it's just confirming that this is correct. So however nested this would be, you could view the files as such. And we can also see quickly, these are some of the exports. So that basically this component just has a global state variable of a count, and then you can increment that count, or you could and you can retrieve it, and it has some other fancy ones, but we're just going to go with those. So the first thing we're going to do now is create a counter worker. So I'm just going to generate a worker name so that it's kind of, actually I'll just do counter one, creating a counter component of a counter worker, and then we'll create the worker, and then we'll navigate to it. And so this is the new layout for a worker. It has a lot of information. Something that's really built into the view now is the live connection. So we can see like when this green badge is on, like when you first reload the page, it spins very briefly because we're initiating WebSocket connection with the worker live. And so this we're basically subscribing to any invocations that are happening, as well as like console output and log output. So, and there are a few different views for this, but this is just because we haven't invoked anything is a little bit bland right now. So there's also the live, and then we can also like step into the files. So these are basically showing that the files that were available that we configured for the component are available in the worker. And so if you were to create new files or anything, that would also show up here. And so we'll just quickly go into some of the different functions that are exported by this worker. So one of them being getting the global value. So because this is a new worker, if we invoke this function, we should get back 0. Like the global value is 0 because we have never incremented it. And so we'll increment it by 1. And then we can go back to the global value, see that that new value is 1. And so after we've had some indications come through, that's going to kind of populate some of these graphs. So you can see like, oh, in this minute of, so at 1:36, we had 2 indications come through, or 3 indications come through, get global value and increment global value by, and they have this sort of distribution. And so this kind of view, these graphs kind of change over time as you get more implications. And another thing to look at is that we also have events for how long each of those invocations took. So automatically, the most recent ones that are live, like we have those like stats available to us, just taking the difference of the start and end time. And so now that we've looked at kind of the new UI for workers and components, we can step back out to creating an API. So we're going to step all the way back out to our project view, and we're going to go to the APIs. We don't have an API. We're going to create a new one. So we're just going to say like counter API for the name, and then we're going to put a version here. And now we're in our API view. And so an API is comprised of different routes. So we're going to build some routes. So given that we're going to be building off of our counter component, we're just going to basically build 2 routes, one for retrieving the existing count of a worker, and then one for incrementing it. And this will kind of showcase some of the features that Offcell built into RIB and the type inference that's available to us. So I'm specifying here that the path of this HTTP route is like counter ID. And so these brackets indicate that it's capturing a variable. And then basically we're going to initialize what component version to use. And what's interesting here is we basically have a few different places where we can use RIB to kind of massage the data that we're expecting into a form that we would like. And so right here, you can see that this is actually referencing the counter ID that's available in the path, and it's saying that it's a string type. And so you could, if you wanted to, it doesn't make sense here for the worker name, but if you wanted to put a different type here, it would kind of specify that this variable type is of that type. But for now, we're just using string here. And then the thing that we want to do is actually just call the get global value method. And then we're going to return that value in an object where the key is value. So maybe just make this look a little nicer. And so we're basically, this is a RIB input and this is a RIB input. And we'll go ahead and create the route. And this is just, again, that GET request to retrieve a counter's value. And so we can see that like we have some data available to us saying like, for the input request, we need a path parameter counter ID. And so this is actually going to get a little nicer with the post request. So we're going to also make another endpoint, one for incrementing the value of a counter. So we're going to go ahead, do the same thing here. And have the same worker name. So basically associating a worker for this specific counter ID. And then here we are going to do a little bit more complicated of a RIB script, where we're going to specify that the user must supply an integer in the query part of the request and as a query variable, a query parameter, with the key increment, and that we're going to pass that to a function here. So basically here we're specifying that we need this increment value. And then after we've called this, then we call the get global value because the increment doesn't return us anything, so we can get the new one. And then in the body of the response, we're putting this new value here. So we'll go ahead and create this route. And so basically here you can see both like the path parameters you need to supply a counter ID, and that you need to supply a query parameter with increment. And that once those are given, then like this route would actually succeed. And so yeah, that's pretty much the main idea. There also is a response data type, but that there's a little bit of an issue there on the UI side, so I have to fix that. But this is already a really, I think, pristine experience in terms of exposing workers, and you get an API like within a few forms, like a few clicks and a few forms that you fill out. And I think this is also only going to get better. Like we're planning on expanding this to have like pretty much like a full like little IDE experience here with some syntax highlighting and some suggestions and stuff. And so this is already very easy, and it's only going to be getting better. So I hope that if this makes you excited, that you continue to pay attention and like are excited about the future of Golem as well. So I think that's it for me. Yeah, I think I've covered everything I want to. So I'll hand it off back to John.
All right, fantastic. Thank you, Nico. All right, so I hope you can see that an enormous amount of work has gone into this release. I think the Golem engineers have been very, very busy making it probably one of the most impressive releases to date, just in terms of the amount of improvements made across the entire platform, from the UI all the way down to the core platform. So really exciting stuff. Now let me go ahead and finish up with a sneak peek at 1.2. So I don't think the themes of 1.2 are significantly different. I think pretty much in the early releases in 1.2, we're just all focused on improving usability and making sure we have the right extension points, and then making sure we provide that out of the box experience where everything is there and you don't need to reach outside of Golem in order to implement something that matters. And in service of that, the 1.2 milestone, which will correspond to a February release date, is including all of the stuff you see here. I'll just briefly run through what they are. Component resolution solves a usability issue. Right now, you have to reference component IDs whenever you're trying to do worker-to-worker communication. And that makes sense because component ID is something that's not known statically. It's only known after that component is uploaded, but it's not very pleasant. And it's nicer to support resolution by name, which is something we're going to do as part of 1.2. Stubless RPC is about further simplifying worker-to-worker communication. We really want to get it so simple to call some workers from other workers that it's just part of your ordinary development experience. You don't have to think about that. You don't have to configure anything. All you have to do is go to that YAML file and add a different directory, and then you can just immediately begin interacting with that worker. And one of the things that we're trying to simplify with this subless RPC feature is removing the need to generate on your machine the stubs and compile them to WebAssembly. So after we implement this, you'll go ahead and you'll make that change to the YAML file, and then the server, the Golem server, or maybe the single executable, if you're running Golem locally, is going to be responsible for dynamically adding the stub. So it's going to see what remote component you're going to invoke, and then it's going to automatically add all of the logic and serialization and deserialization and so forth that are necessary in order for that RPC call to succeed. So that will mean you don't need the Rust toolchain anymore. Previously, you've had to install the Rust toolchain in order to do worker-to-worker communication, even if you were just using TypeScript or JavaScript or Go. And after that change, you will no longer need the Rust toolchain because we're going to be adding these stubs dynamically on the server side, which is really exciting. We're also going to be enhancing the command line experience. So I think right now, through the work that David has done, you've seen some of the usability improvements to come forth from the Golem application manifest file, but there's a whole host of things that we can and should be doing in the command line experience to make sure that you don't have to type things. You don't have to type component IDs. You don't have to even type component names in many cases, right? Because we now know with this application manifest file, we actually know something about your application. We know all the components. We know everything that's in there. So we can dramatically simplify the experience of using the command line tool by taking advantage of that information. And so we're basically going to totally refactor the command line interface in order to do that. Console, as you can see from Nico's demo, has undergone so many improvements. It's a totally different experience, and it's really nice and pleasant to use. And we're going to keep on piling on the enhancements in the next version. You're going to be able to share components and share projects with people and do all of that in a visual fashion using Console. And there's going to be an ability to see plugins and visually install them and add them to projects and also to components, and so many other great things coming to the console. We're going to be adding configuration and secrets. So right now you can already configure your workers through environment variables or through files. So you can actually ship config files with them. But also it's useful to have runtime config and secrets and type config. And so we're going to be adding support for some WASI standards around that in order to make sure that you can very easily configure both everything in a project as well as everything, all the workers created from a component using the console, obviously, but also the APIs and command line and so forth. We will have, built on this plugin machinery, we're going to have our very first plugin available in our sort of plugin marketplace, which is OpenTelemetry integration, which is going to generate metrics and traces and stuff. You won't have to do anything other than install this plugin into your component. And this is going to be basically to prove out our plugin system. A lot of the plugin features have been designed with things like OpenTelemetry or database access in mind, but we need to ship a few of these to make sure we have exactly the right feature set, and OpenTelemetry is going to be one of the first ones. The goal is, at some point in the future, if you need a database, or you need this API or that API or this cache, or you need OpenTelemetry, or you need logging, you should just be able to go into this marketplace of plugins and click, 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 and boom, you have all that stuff and just that stuff. And all of that is done in this extensible fashion, which is really taking advantage of the power of WebAssembly to offer security and sandboxing, isolation, and so forth. Worker debug is a new feature that will be coming in 1.2. And this is really, really, really amazing. You're going to be able to grab a worker ID. So maybe that represents a request, or maybe a workflow, or maybe it represents a shopping cart, or whatever you want it to. But grab a workflow or a worker ID and plug it into the debugger. And then you're going to be able to play back from the very beginning all of the different operations that occurred. And not only can you play back, but you can like interact with this old version of your worker, maybe before it encountered the fatal problem, and so forth. And you're going to be able to attempt limited worker recovery in some cases. So not only can you go back and understand what went wrong, what series of steps did this worker take to get itself into a failed state, but you're also going to be able to attempt worker recovery by saying, oh, we're going to rewind and we're actually going to resume execution from this point. So that worker debugger is part of our attempt to give you this amazing experience for diagnosing, troubleshooting, and recovering problems that are occurring in your distributed application. Invocation context is a new feature that's going to allow you to pass context every time you invoke one of your workers from the outside world. So think REST API or GraphQL or gRPC or something like that. You can attach some context to that invocation, and it will be seamlessly propagated into the worker that's being called. And then as that worker calls other workers, it's going to be propagated automatically, transitively, as far down the dependency call chain as necessary. And then at any point, workers can choose to pull that information and say, hey, what's my execution context? But also they can add information to the execution context. And this is going to be how basically we do sort of, cross component tracing. And we have really good, support for spans that cross invocations across different workers. It's going to be a key component in the OpenTelemetry plugin, but you're also going to be able to use this to do all sorts of really interesting things. Like you could imagine injecting the authenticated user email or whatever into the invocation context in your first worker, and then all of the downstream workers, doesn't matter where they are, just have access to that authenticated email. So you're going to be able to use this to do some pretty amazing things, just in general, propagating context across your distributed graph of different stateful services. Worker recovery, I mentioned that already. This is the ability to take a worker that's in a failed state and go back and try again from some earlier point. And maybe the issue that was affecting it then won't be affecting it now. We already automatically retry failed workers from that very last point, but you might have to actually back up a bit and pretend that some things didn't happen. And so we'll support that, and we'll have, of course, command line interface to doing that, as well as console support for that worker recovery. And this is the beginning of worker recovery. There's actually a lot more we can do here. We could do things like, well, maybe there was an error in the data, and that's why the worker failed. And we can go back and allow you to go back in time and see what that data was and manually modify something and hit enter. And now you've corrected that corrupt data. So now you can resume it and the worker won't enter a failed state. We're trying to provide really high level and very powerful tooling for dealing with failure scenarios, because using Golem is a sign that you're dealing with, I think, mission critical code because of our support for transparent, durable execution. So providing support for not just seeing when there is a fatal problem here in one of the workers, but actually resolving that, even if it was a mistake in an end user or API or developer, is something that's very important to us. And then finally, the last, I think, very significant feature is this feature called compositional durability. And the main thing that you'll notice out of that is a new set of primitives added to Golem's low-level API that will allow you to, if you're building libraries in the WebAssembly ecosystem, it's going to allow you to tap into this lower-level API to add custom durability to whatever library you're making. And this is not intended, I don't think, to be used by end users of Golem. This is more something that if you were a library author or framework author or someone like that, then you could utilize this. We will utilize this ourselves to basically bring durability to all of WASI. So WASI is the POSIX for WebAssembly, and it's what like Rust standard library uses to do file O and all that stuff. And behind the scenes, what we're doing is using our new low-level durability API to make WASI durable, but as a proof of concept. But if we're able to do that, and I think we will succeed in 1.2, then that means you can take and you could make a database layer that also uses these same durability primitives to customize the behavior of what happens. How is this made durable, right? One of the things with databases that you need to get right in the context of Golem is exactly one's execution semantics. And so in order to provide that, you need access to the same low-level primitives that we ourselves need when we're bringing durability to WASI. And this is the ticket to that. This is the ticket to basically not having, for an end user developer, this is the ticket to not having to ever think about durability because it's just baked into whatever libraries you're using. All right. So that's 1.2 milestone, which will come out in February of next year. And I think that's a lot of exciting stuff we'll talk more about. All right. Well, if there are any questions, I am happy to take them on the Golem Discord. If you're not already on there, then I would recommend you hop on there. Let me just take a quick peek and see if we have any questions. Speak Freely asks, will Golem have any interop with Zio? I think that's a great question. And we are sponsoring, actually, I think some significant work. If that ends up being successful, it's open source work. If it ends up being successful, then it will mean the entire Scala ecosystem can compile their applications to back-end WebAssembly, which would mean you could build a Scala application, you could compile it to a WebAssembly component that then runs unmodified on Golem. And I think that's phenomenal. It's necessary though before we can think about Zio integrations with Golem, because really we would want to have a Zio API for all of the Golem primitives, and we would want to make sure that Zio's way of thinking about things, like with region-based operators, works really well with that Golem API. We would also want to make sure that we brought the Saga pattern directly into Zio, the Zio ecosystem, powered by Golem's durability features. So there's a lot of really great things that we can do there, but ultimately it comes down right now, our limitation in doing that comes down to the fact that Scala does not compile to back-end WebAssembly. It can only compile to so-called front-end WebAssembly. However, that's a step in the right direction. So from compiling to front-end WebAssembly, it's actually a modest step. It's still not a small amount of work, but it's a modest step to compile to back-end WebAssembly and support the component model. And that's what the work that we are currently sponsoring is aimed at doing. So I would say with a little bit of luck, probably by the time we release Golem 1.2, you'll at least be able to run Zio apps on Golem. I hope. Obviously, our open source sponsorship could go sideways, and it could prove to be harder than anyone imagined, and maybe that fails. But if that does not fail, I would expect around the February timeframe, you'll be able to run Zio applications on Golem, which is a big first step, I think, for the Scala ecosystem to start benefiting from this really great durable execution technology. All right, no other questions? So we'll go ahead and wrap this up. Thank you for sticking around for nearly 2 hours. And I will see you all, at least in the context of our release update, in about 2 months' time.